Cool. So I'm Kiru, work for ThoughtWorks. I came here from Melbourne, and this is my first time here to Wellington. And it's glad to see a group of enthusiastic bunch of people. And I think it's like a lot easier to do a talk like later in the afternoon because a lot of these things are actually interrelated. So when you say event-driven, so event-driven becomes really applicable when you have like a lot of moving parts. So if you have already gone down the path of microservices, that's when you kind of feel like, oh, maybe should I start thinking about event-driven? And because we have like so many people spoke from the morning, so they covered all the basic important parts, like we know what a good microservices architecture is, and we also heard a lot of different examples in different talks where the tools are actually using event-driven. So like the one in KEDA, like where it's actually using event-driven behind the scenes. So, and also like event-driven is it's one such term where it's like so broad and it's very abstract. And when someone says event-driven, I'm pretty sure like everybody in the room would have like a different set of expectations in your mind. So maybe we'll just set some scenes as like what we're going to talk in the next 30 minutes. And the first thing is we're not going to talk about the architecture because there are a lot of different talks in place already which talks about architecture, styles and patterns in event-driven world. I'm sure if you're keen, you'll be able to do a simple Google search and get onto it. But what I want to share is my experiences in building and designing event-driven systems. So this is based on two different projects. So one was from a startup world, and we did not go with the event-driven mindset from day one, but eventually the system evolved into an event-driven model. And the other example is from a banking enterprise world, maybe because of the buzzword, and we were a bunch of people who have already done event before, so we started doing event-driven right from day one. So we'll get started. So I'll start with the startup example. So this is in a fintech, and before even we could form a team and start writing code, this investor, they were really pushy, and they were like, you should start pushing the features out as soon as possible. Show me this growth and numbers and blah 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 blah. So before even we could form a team and start writing a piece of code, they bought a different company, and we started on day one with a piece of software in place. So as you're guessing already, that's the reason why, like on day one, we started with kind of a monolithic architecture, but we were very clear in our mind from day one that like, okay, we're not going to continue this forever. Like, sooner or later, like we need to break it down and we need to do it in our own style. And we started with that, and we'll kind of, take this journey through a simple example. So the one I want to pick is from an insurance industry. So if you have like a home insurance, so the premium for your insurance is calculated based on a number of different attributes. And one of the attributes for your premium calculation is your home location. So assuming that like you move your home. So you were living in a far suburb somewhere, and you move somewhere closer to the CBD, somewhere in a nice, closer to water. And because the risk varies, so there's a risk of flooding and blah, so you need to pay a bomb for your insurance premium now. So you change your address, and it makes a request to the existing monolith system, and it does a couple of things. So the first thing is because the address has changed, so that change needs to be updated in the system, so that needs to be captured there. And based on the change, I need to recalculate your code. So I need to say what's your new premium. And the next thing is, okay, I do all these things. Sometimes, when I change home, I don't have it in the back of my mind that my insurance is going to change. So I'm going to get an email or a letter from the insurance company that, hey, great, you moved to a new place, and also you're going to pay me more from today. And if it's a monolith, or if all these things happen within a system, and everything is like a function call or a method call. So it's like all or nothing. So everything fails together, or everything finishes successfully together. And like I said, in our example, like we started with a piece of software which we inherited from the company that we bought, but just 3 or 4 months down the line, we were pretty sure that, okay, we started actually, strangling things out of that single piece of software. And the best, probably one good learning for me from that experience is like we didn't think too much about the reuse, but rather when we did this, we thought about like how would it actually help me to do things quicker. So it is more about the business innovation, even over technology innovation at that point. So we spoke a lot about microservices. So what is a good definition of a microservice? So it's a small, and again, there are different definitions of how do you define the right size for a microservice. But if you ask me, like probably it's a service which does one business function or business thing properly. So that's a kind of a good enough size for a service. And autonomous, I think we spoke about that enough, and I think like we are at a point where everybody kind of understands and we have seen the pain points. So it's like autonomous where you would be able to do it from development to deployment autonomously without any dependencies on other systems. And comes the last part, which says that works together. That's where the complexity and the choices appear. And that's where you need to be really aware of what is your existing ecosystem and where is that you want to go, what is your future state, and accordingly take good decisions along the way. So when I say work together, right, typically for me, the default option of working together is when you have a service A, which makes a call to service B, and it's a request and the response. And for me, the default option is like, okay, I request something and I wait for the response. So it's like a synchronous request and response. And then the next step of evolution could be, okay, is there a possibility where I need not wait for a response from the service? Rather, can I just make a request and get on with my work? And when the response is available, I'll start consuming it. So that's the next step of evolution. And the next step could be where you find opportunities in your system where I just notify something happened. So like in our example, it's like address has changed. So I just leave that notification in my ecosystem, and whichever system is interested in that particular piece of information, let them consume and let them do whatever they want to do with it. And again, the next step could be where I publish something and then I wait for a response asynchronously. So again, like different choices and different patterns, but because I know the way we start thinking is like in the monolithic thing or in a system thing. So in our brain, it's like, okay, I make a request and I need a response, and that's when kind of I feel safe and secure that the call I made is successful. So going to our example, like we had a monolith, and then everything was within a process. It's like just a call to a method or a function. And then we moved on with, now we have like a couple of services in our ecosystem. And it's like kind of a request and response pattern. So you can see that there's like a lot of, like calls between these services. So like kind of if you take a moment and see, like in a monolith, you have like a lot of tight coupling between those components, but more at the code level. But here kind of, we get a lot of benefits in moving from monolith to microservices. But at the same time, like we also have like a degree of coupling still existing in our ecosystem. So for example, in case of failure, say, one of these services fail, like what happens? Like, does my whole system come down? So does it have a cascading failure in place? Again, we have like a lot of good patterns in place. Like, people spoke about circuit breaker, and you need to have like a good retry mechanisms. You need to think about your timeouts, like how do you want to handle it? But all of these patterns would help you to fail gracefully, but it will not help you to be successful eventually. So like everything is like still synchronous, and it's like still RPC calls, which is like blocking. So going back to our example of in insurance, so how does this look like now, like in the microservices world? So you change your home address, you get a new address. So probably you may have like an API, which will actually be called with the information about somebody, this person changed the address, and this is a new address. And probably this service might make a call to another service, which will help you to recalculate your code. And one of these services might make a call to a communication service, which will actually send an email to your inbox. And imagine okay, this is what your current business looks like, but they're talking about expanding it further. Okay, there's everybody's talking about big data, everybody's talking about analytics. So they hear in a conference somewhere that an airline is actually able to forecast their business for the next 2 full years. So how are they doing it? Things are backed by data. Okay, I need to do more. Can you help me with it? So I need to do my, give this data to my pricing. So I need to understand, because of this change in the premium, how is my business impacted? So is that going to have like an impact on my forecast? So there are like a lot of different business units who would be interested in this piece of information. So the direct person who is impacted is the actual customer, where you need to ensure that, like, as soon as the address is changed, you need to ensure that the new quote is calculated, and that has to be informed to the customer. But at the same time, there are a lot of possibilities for you to expand it beyond the direct transaction. And if we have to do this with our existing architecture, so we need to identify which is that central piece of component which will orchestrate these calls to different services. Probably you might have in-house developed a service for pricing, which will take all the information and do your analysis and kind of give you nice graphs and give you all the information you need. You may have an existing forecast service, but these are not going to be synchronous, right? Like, I don't need to do my pricing analysis. I don't need to look at my forecast for every change of my premium. Rather, probably I might look at it when there were 10 changes, or probably I might look at it when there's a change where there's an interesting number. If somebody moved to, and say, home which is built in 1800s, oh, something is really interesting, it's an outliner, how is it going to impact me? Like, I'm interested in that, I'm curious to know about it. So if you need to expand your business in that perspective, so with an existing microservices architecture, if it is designed in request response, it's not really that easy to do it. Rather, kind of, if you take a pause and think about the same example in an asynchronous manner, so it gives you resilience. So I don't have to build services which will request to something and wait for a response. So I get a degree of resilience there. And it also gives me a flexibility to kind of build my platform. So my platform, my components could easily evolve over time. And it also gives me an ability to kind of replay, because there is no synchronous wait. So I can capture the state of my system in some format somewhere where a forecast system or like a pricing services can come back and replay on that state of the system and then process it. And while actually preparing for this one, like, I came across a report from Gartner. So it has like a lot of interesting numbers, and one of that is like kind of talking about the amount of data which would be generated by 2025. So the last bar which you see is the amount of data that eventually the companies would actually store persistently. And the last one, where you say around 225 zettabytes of data. Actually, I had to go and do a Google search. I don't know what was zettabyte. It is actually a billion terabyte is 1 zettabyte. And 225 zettabyte is what is going to be the amount of data which would be generated. And the most interesting part is what is there in between, where 25% of this data is going to be real time, which means there will be an inherent expectation from your consumers as well that your apps or your systems would behave real time and would react to that information real time. So going back to our example, so think it's slightly different. So you still have those services, APIs in place, but instead of having synchronous calls between these components, so how does it behave if you have like an asynchronous call? So it makes a call and kind of publishes the information and doesn't wait for the response. So there's a kind of a trust in the system that the consumer will do what it needs to be done. And this whole concept is not anything new. Like in my very first project, like when I was an intern, we used something called Mule ESB. But frankly, honestly, at that point in time, like I did not really understand why I was using it or what benefits would I get out of it. I just used it because somebody in my project told that's what you need to use today. So that's kind of it's kind of still aligns with this concept. But at that point in time, like when I started, there was no cloud, there was no AWS, there was no concept of microservices, which is well defined and understood. There was no continuous deployment. So it's like kind of slightly different world, but the concept is still the same. So it kind of, if you use the ESB in place, you still get a degree of, asynchronous, but the whole design of the intention behind, these heavyweight, ESBs are like where it helps you with off-shelf, legacy system integrations, and it kind of still, behind the scenes encourages, a certain degree of request response pattern. And what if we move this a step beyond and, kind of recollecting whatever we heard from the morning, that there are things like, event streaming. You can actually publish events real time and consume events real time. So if you remove that ESB in that and introduce event streaming in that place, so how does my architecture look like now? Okay, I change my address and it's an event. So I'm just going to publish it to a stream somewhere and I'm done with it. That's my job. And there could be something else happening and the event is captured, and there could be a code service who is always curious and interested to know if an address changes. Okay, whenever someone publishes an event related to address change, I'm just going to consume that immediately and respond to it. And there could be a different consumer, say, in our example, like pricing or forecast analysis. Okay, I'm still interested in that event, but probably I'll not consume it every time it's published. I'll come back and consume it at a later point in time, and it's up to me to decide when I would consume it. Okay, we spoke a lot about event, and it's kind of such an overloaded term. So what is an event? Like, what do we mean by that? So my understanding of event is a fact, in the sense like a thing which actually happened, and with no expectation of consequences of future actions. Say, for example, like in our example, like address changed. So that's an event. So that actually happened. So it's not like a request or it's not a command. It's not like go and change the address. It's like an address changed. So it's like a truth or a fact. It just happened. So the mindset is actually how do I what are the different events in my business process, in my workflow, and like what is that like I need to capture between the services. So going back to our example, like what does that look like if we capture the whole thing with events in place? Okay, I change my home and address changed, and that's captured somewhere in my ecosystem. And there are different consumers who are actually interested in that particular event. And there's a code service which will actually come and consume this event as and when it happens. And there could be a claim service. I might have an existing claim. So the insurance company might really want to check if that claim is on your new address or an old address. So that gives me a flexibility that, okay, if there's an existing claim, okay, the claim service might also be interested in consuming it. And I can extend it a lot easier. So you see that, a degree of evolution, it's a lot easier in this style of architecture compared to what we had before. So similarly, if we expand it, okay, an address changed, that's an event which is published. There's a consumer who's interested in that. Okay, the code is regenerated. Okay, I need to pay more premium now, of course. Okay, and that generates another event. And there could be different consumers again who want to interested in that. Okay, there could be a service which is responsible for sending out all the communication. Okay, send it out, and this could be actually consumed by what's your new price. So that could be consumed by pricing, and it could be consumed by forecast. And because we are going to capture the state of the system somewhere and have it persistently stored, so I can have consumers which will come back and act on it at a later point in time. Say, for example, like as of now, like I may not have like a good analytic platform in place, which is something I'm still building. I don't have a data platform, but I have started collecting my data like for the last 2 years. So in my current project, like actually we are building the data platform, but we're just building it now, but they do have data for the last 3 years, which is like well captured. So like kind of it gives you like a lot of opportunities to kind of expand, both from the technology space, but also from the business space. Like say if there's an audit, like tomorrow somebody just pops up out of nowhere, or Australia, New Zealand, we start go down the GDPR way, and like I need to do an audit, I need to show everything. Okay, cool, I have all my state, everything is there, as part of events. Okay, go ahead and read that and consume it. Okay, just want to highlight a few things which I learned through my experience. So event are things which are not mutable, it's like immutable. So once happened is happened. So if I go back to my old address, it's not like go and edit the event or delete the event or ignore it, but it's like another change again. So if I go back to my old address, it's like another event, and that's the change of, it just captures the data. And it definitely grows over time. Like, so if you think about in your ecosystem, you have like a lot of events happening, and it cannot be retracted. So a consumer can actually ignore it. Probably you'll have like some services in your ecosystem which is not interested in event of where the address changes. So you can just ignore the event. But like once you consume it, once you read it, like you cannot retract from there. Now comes to our point. So our brain is always fine-tuned to think in a way that consistency is the way to go. So however I solve the problem, I need to ensure that consistency is in place. But think about an example like where, if you've used any e-commerce website, like say Amazon, especially the ones which has like third-party fulfillment, like where they'll just list things in their website, but that will actually be packed and shipped by somebody else, like it could be from a different country. So if you place an order in an e-commerce website, so they do not have all the data from the third-party service which tells you whether this particular item is in stock or not. Say like I ordered an merino wool-based cap which has to be shipped from New Zealand, and like I placed an order, I got an email that okay, your payment is done, I took your money, and your order is successful. Like you're going to get your product, more details pretty soon. And then after an hour, I get another email saying that oh, something went wrong in our system. I'm sorry, like we are not able to fulfill your process. We're just going to refund you. Please come back and look at other products in our site. So what companies like Amazon actually doing behind the scenes is that like everything is asynchronous. Like so you place an order, okay, you need to make a payment for that order. Okay, I'll do it. I'll capture those events. So an order has been placed, and that might have an event. It will have some details like this is a product, this is a price, blah blah blah. And later the third-party service might come and say, oh, I'm sorry, this particular product is not in stock. Okay, I can't fulfill it. Okay, so in the e-commerce point of view, it's not actually stopping the customer from making the purchase. So it lets you do the purchase, but there could be legitimate failure scenarios where the third-party service is just down or it's not reachable. So in that case, like eventually after after an hour, it's going to come back and say that okay, your order is good, successful, all good. But if it is like legitimate, like if you really don't have things in stock, you can come back and say that oh sorry, like, and then remediate on top of it. Okay, so it's like embrace it. Like think about it. Like if you're actually thinking about events, like think about it. Like don't think that like you need to solve it consistently, but think about how do I actually design systems so that like eventually it will be successful. And what we're not going to talk in detail in this thing is like different patterns, but I'll just like want to highlight like include a lot of links and sources. So if you get access to slides, you'll be able to use them. So these are the common terms you'll come across when you search for event-driven architecture. So it's like the notification where you just notify something happened and it stops there. And event carried state transfer, it's like your event gives you all the information that you need to act on it. So in our case, address change, it gives you all the information as this is the new address and this is the old address and whatever you need to act on it. And event sourcing is where like kind of you encapsulate your state of the system and store it persistently in a sequential manner. And I think CQRDS is like kind of quite popular. Like we have an idea what it is. We're not going to talk much about it because like there are tons of good videos and links out there in the internet. But what we're going to really touch upon is like some traps and some tips based on my experience in building systems of this sort. So the first thing is bad data. Like I said, like we started with the monolith, and then very quickly we went down, to microservices for all good reasons. But at that point in time, like we did have data stores and databases. So when we moved from that point into event-driven, what we initially did is try to kind of capture events which actually replicates what's captured in our database. So what we ended up doing is some of those events actually reflect our basic CRUD operations and not the actual business events. And then again, because it was an existing system, I had an idea about the consumer. I know what I'm going to actually fulfill. I know who's going to consume it. So, kind of in our mind, we started thinking more, evaluating like what I'm doing, what I'm capturing in my event, is it good enough for the consumer, or would they be needing something else? So eventually it went to a point where like kind of we started adding too much information into the event, and it's like, bloated, and kind of it didn't actually solve the purpose of what we wanted to do. So we had to kind of take a step back and correct our mistakes over the time. And again, things like, for example, the best example for this is like order placed. So when we say order placed, is that an actual business event? So when you say order placed, like what do we mean? Is it like the payment is done, or is it like the order is actually fulfilled, it's completed? Is the order delivered? So what is it exactly? Like, because in the request response pattern, we don't really align it directly with our business workflow. But when you actually move a step from there and try to capture the business events, it might be like a slightly different mindset. So probably what I would say is like start small and kind of validate if you're actually doing it right, give it time, and then kind of evolve it. Don't go like a big bang, take whatever services you have, like kind of shift it to the event-driven one. And again, like too much focus on the consumers, because the whole idea behind this is where the producers will have no idea about the consumers. So you don't have any degree of coupling at all. So it has to be agnostic. So from the consumer point of view, my intention in our example is like address changed. So I just need to ensure that the change of the address is captured properly, and it needs to be published to the to my ecosystem. That's it. So don't really worry too much about the consumers when you're actually designing, thinking about like what gets into my event. And again, a lot about the event design itself, like how do I actually capture it? So dependencies between the events. So this one was like a really good example. So we had like kind of a mini checklist we had. So every time I design an event, like kind of we had a checklist. Okay, these are the things kind of we spoke about it in our team, or kind of we validated it as a group. And one of the top things is like dependencies between the events. So a good design should be in such a way that like, okay, if I publish an event, for a consumer to act on it, it should not wait for another event to be made available. So if you're doing it that way, there's like, you see that dependency there. So I have an event, I need to act on it, but for me to act on that, I need another event to be made available on the system. So there's like a sense of, coupling there. So if you get into a scenario like where you need to do that, then probably you need to stop and think, okay, maybe your boundaries are wrong, or maybe your understanding of event from the consumer point of view is wrong. I would say it's wrong, but it's that like it would evolve over time. And the next thing is like leaky events. This kind of similar to what we spoke before, where it has like a direct correlation with either your structure or your entity. Because when I started, it was really difficult for me. My brain was so used to thinking architecture in terms of boxes and lines, and it's more on structure. Okay, what's your data? What's the structure? What gets into it? And not really too much about what happens and the behavior of the systems. So when you initially started, like you might actually map your events to the actual entities and its structure. And assume knowledge. So this is where a producer assumes that, okay, if I publish an address change event, I know for sure that the code service is going to act on it and calculate a premium. So which is an assumed knowledge. Because the whole underlying principle of this is like where the producers should not really think or care anything about the consumer or what they're going to do about it, how they're going to consume this. So we spoke about asynchronous enough, and the other thing I want to highlight is like the infrastructure for the broker or the event stream itself. There are like so many different good options these days. Like probably when I used Mule ESB, like that was not the best choice, but these days like you have like queues, you can use like RabbitMQ or Kafka, like so many different choices. And again, like though personally I have a preference over Kafka, but like kind of every tool has its own pros and cons. So probably when you have to make a choice, it would depend on what's your scale of events and like how good or mature is your consumers, how much can they do within their boundary, or how much I need to be done from these streams or brokers, or what do I have already existing in my ecosystem? Is there anything already in place which I can actually start using it? So like a lot of different questions, but like I'd say like a lot of matured solutions available today in this space. And like quickly on the message schema. So in our example, so after a point in time, almost towards the end is when we started actually giving enough importance to this. And we started using our protobuf. So it's a protocol buffer from Google. So it's like platform agnostic, language agnostic way of capturing your serialized data. And it took a lot of understanding, a lot of time for us to understand what is a good event, like what is the naming for it, what's a good name for it, and what are the different fields. And one of the bad things we did is like when we started with a bunch of mandatory fields, but eventually we realized that that's not a best practice. Like everything has to be optional, and like what are the things I need to capture in an event, what is just enough, what's too small, and what's too big. So it would take time to understand, but just keep in mind that like there are choices there, and there are good examples these days to get started. And versioning, again, it's very important because the whole idea is like where you have your state captured and it's going to stay forever, and you can go back and replay it at any point in time. So when you actually version, when you start with the second version, ensure that the new format, it's not going to actually go and break the existing one. So that's the thing where we learned, okay, a few fields, like with simple things like IDs and timestamps and stuff, we made it mandatory. We thought it's a good thing, so everybody would follow the standards. But eventually, like we were not able to change some of the fields because they were all mandatory. We didn't want to go back and break the existing ones. And tracing, so I think we had a detailed talk about this, so we don't have to talk about this now. So we know the importance of it. And probably the last one I would touch upon is like the complexity of the consumers. So things were like kind of simple in some terms when it's monolith, and when it moved to microservices, we get a lot of benefits, but we get other challenges as well. And when we start thinking about event-driven microservices, you get much more benefits. So it's like you get like that's the next stage of evolution, but that also adds another level of complexity. So there's like a lot of expectation from the consumer point of view that they do all the right work, they're interested to consume it at the right time, and like even things like differences between the brokers like RabbitMQ and Kafka. One of the projects we used RabbitMQ, the other one is Kafka. So in case of Kafka, it's like there's a lot of complexity into the consumer in ensuring that I consume it in a sequential order, I do the required retrace and blah blah blah. So I mean, just to keep in mind that when you actually think about it, when you take your first step, like there are things which is going to be more complex than what you have today, but like you need to kind of give it enough time and ensure that the teams is capable to handle it. So putting it all together, so things are going to change right from infrastructure and your storage, and you have to think about like your events, streaming, what am I going to do, how am I going to do, and services, how are they going to publish these events, how are they going to consume these events, and like even at the level of like apps and devices, it is just not for the transactional events, right? Like it could also be for the behavioral events. So one of the most popular booking website actually does everything by events. You might have seen when you're actually searching for a accommodation in Wellington, it would say that somebody booked it just 2 minutes back. We don't know if it's for sure or not, but like actually everything is event. They just capture it, process it, and kind of act on it instantly. Cool. Just want to finish with this. So we are done with another bingo buzzword for the day. Thank you. Any questions?
Probably a question for me. So how do we enforce all your applications or any other like logging systems follow the same event standard?
So the way we did it is like we defined our event schema, which will get into a Git repository. And when we actually define the schema, it will be like a group of people, like the teams will actually producing it and consuming it as well. And we define that in protobuf, and that gets into a Git repository, and we actually follow the standards from there.
Thank you.
It's like kind of driven by code. So I'd say like, the schema definition actually driven by the code. So it's like how, for example, like the comparison would be like if you had like a log statement, right? Like you can have like a library which actually, captures the standards. Okay, these are the fields that needs to be captured. And when you actually log a statement, you just, fill those actual values. Say you have structure like I need to capture timestamp, I need to capture ID, blah, blah, blah. That's your schema or the standard. So that is actually defined in the protobuf, which is actually captured in our Git repository. Yeah. Thank you.
Thank you, Kiru.